we are going to, I think a wee recap's necessary. So I'm going to do, here's a triangle with 3 sides, and we're going to find some information about it. I'm then going to do 2 sides in the angle in between, do a question like that. And I'm then going to do a third one, which is 2 sides in the angle in between. But I want to show you a question where there are 2 possible triangles, which is pretty rare in the cosine world. For instance, in this world here, there's only 1 triangle. But in some of the 2 sides in the angle in between, you could get 2 separate answers. And so we'll do that. And then after that, we will work on some applications. And if we get those finished, which I hope we do, we'll do a little early look at trig identities, which is the next section. The next section, regardless of how quickly we get through these, is not going to be in your test. Yes, there is a test. And your homework. And your homework is 1 section. So hopefully that'll make your weekend go a lot smoother. Right, so here's a pretty standard question. It normally would be, fill in all the missing angles or fill in one particular angle, depends how they want to phrase it. So let me ask you a question right off the bat. Which one of these 3 angles, A, B, or C, must be the biggest? And don't look at the picture, because the picture's no help.
A.
Say the letter again, I didn't catch it.
A.
Correct. Why?
Because it has the biggest side.
That's right. And won't B be the smallest angle? Right. So when you're doing these questions and you've filled in the missing angles, right? Suppose it's one of those fill in everything questions. We have a quick look that that's true. So if you think this is 13 and that's 60, won't you say to yourself, wait a minute, that can't be 13. That has to be much bigger, right? And who knows, maybe you forgot to turn into degrees. How about that is the most common mistake everybody does, right? Maybe that's what went wrong. Right, in this question here, what do you want, A, B, or C? Pick one.
C.
Okay, so we need a formula, don't we? And there's a pattern to them because there's 3, right? One for angle A, B, and the other one for angle C. Anybody want to have a shot at it? What's the formula?
13 squared plus 8.
Oh, that is correct. Can you do the letters first?
Oh, sorry. It would be A squared plus B squared minus C squared over 2AB.
And I'll just fill in what you were going to say. You're going to say 13 squared plus 8 squared, take away 10 squared, all over 2 times 13 times 8. Are we all comfortable with which formula goes with which missing angle, and then plugging in the numbers, right? Now, I like to do this in one big go. That way I only need to use my calculator once. Some people choose to do it in 2 steps, and that's also okay. This has been low battery for days, so I'm just going to keep going with it until the battery does die. Make sure, and I am in degrees, so inverse cosine, and then a bracket, 13 squared plus 8 squared, take away 10 squared, divided by, put in another bracket, 2 times 13 times 8, close some brackets, and the answer I get is, well, to 1 decimal place, is 15.3 degrees. And I'm going to put that into my picture. 50.3 degrees. Now, I'm not going to find angle B and angle C, but couldn't we use the cosine rule to get A, and once we got A, add up the 2 that you know and get the third one, right? And couldn't I also use the sine rule instead if I felt like it and get angle A or B, it doesn't matter. And once I got that, got the other one, right? Are we comfortable? So far, so good. Right. Now, if I asked you to find the area of this triangle, we can actually get it right now. We don't need to do anything extra. What would be the calculation to find the area of this triangle here?
1/2 A times B sine of C.
I'll do it. Which is 1/2 times, okay, slightly out of order, 1/2, 13 times 8 times the sine of 50.3 degrees. Sorry about the mess. I'm just going to put a half in as 0.5 times 13 times an 8 times the sine of 50.3. And that comes out, well, 40 square units. Right, are we pretty comfortable now that if I give you a triangle with 3 sides, you can do everything you could possibly want, right? Get all the angles, even get the area if they ask you. Feel comfortable about that? I picked C. If I wanted to find all the angles, do I need to pick C? No, couldn't have picked B because I felt like it, or A, right? So it's pretty flexible about what you do. So the next question we want to talk about, and we're going to do 2 of these guys, and that's going to be the questions where the information is 2 sides and the angle in between. So call this A, B, C. There's a little A, there's a little B, a little C. It's 10. And just to be awkward, that's 3.5. I want to be safe here. Let's do 13.45. And this angle here is 31 degrees. Now, if you want to find the third missing side, you can do it in this combination. So as long as I know 2 sides and the angle in between, I will always be able to find the third missing side. In this case, it has to be A, right? It's the only side that's missing. And so the formula is A squared equals, right? Anybody want to try this one? What's the formula for A squared? No takers yet? What's the formula for A squared?
What I do is I just plug it into like the normal cosine like equation, and then I just solve for the missing number.
Nothing wrong with that. That works fine.
So it's a difference.
No, it works. Okay, how about B squared plus C squared? Anybody want to finish it off now?
Mine is 2BC cosine of A.
Right. Since most people are going to do it by a formula, okay, it's probably, for them, it's good that they get practice at, using it and writing it down. So in this case, it's going to be 13.5 squared plus 10 squared. Take away 2 times those numbers times a cosine of 31. The good news about that question is simply that I don't need to do anything except write the whole thing down. I don't need to worry about brackets. So it's 13.5 squared, add 10 squared, take away 2 times 13.5 times a 10 times a cosine of 31. And the answer I get is 50.8. Of course, A is going to be the square root of that, so I guess I should have planned ahead. So the square root of 50.8 is about 7.1. So I now know that guy. Now, once you have found the third missing side, can't you then go on and find angle B and angle C? Now, I could find angle B 2 different ways. Couldn't I do the cosine rule because I know all 3 sides? Or I could do the sine rule. If I wanted angle C, cover this up so it doesn't distract us, I could use the cosine rule again, or I could use the sine rule. So a lot of flexibility, right? There's more than one way you can do it. So the next question is similar to that one. You're going to get two sides and the angle in between. But what we're going to do now is give you a situation where two triangles can happen. And I think there's only two examples of that. If not, I think there's only one. I am right, there's only one. So in this triangle, we'll call this A, call this B, call this C. There's your little A, there's your little C, there's your little B. And the information they told me is little b is 122. Little c is 165. And angle. What? I wasn't expecting that. I take it back. I mean, it's a valid question, but I'm just confused why it's here. Never mind. It's a valid question. Since it wasn't this angle here, which is what was the confusion for me. How do you get any angle or any side? What technique? Sine rule or cosine rule? And now I know why that's there. They're putting this question in to show you that, you know, sometimes a sine rule is the way to go, sometimes a cosine. Okay, that makes sense now. Looking at this question then, there are going to be two answers. Sine rule or cosine rule?
Sine.
Sine.
Right. You might say, well, how do I know it's a sine rule? I kind of do it by negatives. What do I mean by that? If you tell me three sides, it's a cosine rule. If you tell me two sides and the angle in between is a cosine rule. If you tell me anything else, it's a sine rule. So I just remember the sine rule is, if it ain't that and it ain't that, it's a sine rule. Okay. So since this one isn't quite what I thought the question was going to be, continue anyway. Now, are there any angles I can fill in? The answer is no. And what do I know? I know this guy, and I know this guy, and I know this guy. So after all those ticks, would you agree that I have to go hunting for angle C? So we put in those two, and what do we know? We know that the sine of 43 degrees over 122 will be the sine of the unknown C over 165. And if I do cross multiply, I get 122 sine of C is 165, the sine of 43 degrees. And so the sine of C is 165, the sine of 43, all divided by 122. So to get the missing angle, you take the inverse sine of that horrible mess. So here goes. Inverse, oops, try that again. Inverse sine of 165 times the sine of 43 divided by 122. And the answer I get is 67.3. Now I'm going to go and put 67.3 here. And that one is definitely going to work. Agreed? What is the other possible angle for C? Right? If you know one, what is the other possible angle for C?
112.7.
Isn't it 180 take away the guy you know, right? Now, back to this picture. Is there enough room in this triangle for 112.7 to live? Yes, there is. That means there's two answers. Can we pretend that was 150, just for argument's sake, right? So if the second angle was 150, is there enough room for 150 to go here? And the answer is no. Are we comfortable about the two triangle deal? Now, the two triangle deal, right, can happen in a situation like this. I don't want to do the rest because once you know that one, can't you get this one?
I
Once
have a
you put in
question.
that one, you can also get that one. Yes.
So if we use the cosine law, is there only able to get 1 degree?
Yes.
But if you use the sine rule, you can get 2.
Yes.
Okay.
Oh, that was a nice way to phrase it. Right. If you think of it, got a picture handy, I'll draw it. If you make a triangle with 3 sides, okay, imagine you made it out of bits of wood, right? So you get a bit of wood 10 inches long, a bit of wood 11 inches long, right? And a bit of wood 22 inches long. Would you agree there's only one triangle you could build with 3 sides? I mean, the geometry of it, does that make sense? Why there's only one answer in that case?
Would
I
that
am not-
triangle even work?
Of course it will. No. Yeah. Okay. So cosine rule, you're going to get one angle. Sine rule, you might, not always, but you might get to. So we are now moving to, is there any more questions? Okay, let's move on to applications because they're the fun ones. I like applications. So there's going to be some story, picture hopefully, and we're being asked to find a missing length, which will be the side of a triangle, or a missing angle. Those questions start at 17, so I'll scroll into 17. Okay, here we go. I'll just do it here. There's a lake here in the picture. There's a person at sea, and they measured that distance, and it was 3.31 miles away. And did another one up here, and it's going to be called B in the picture, and they measured that distance, and that distance was 2.42. And this angle here, you're told that it's 40.3, and you're being asked to find how far apart they are. Right, now as triangles go, if you forget the little bubbly thing, which is basically the lake, don't you have a triangle called ABC? So far, so good. Now, is this length, are we going to find it using the sine rule or the cosine rule, based on just what numbers are in front of you? Sine rule or cosine rule to find this? Right. Tell us why. You're correct.
Because it has 2 sides and 1 angle. It's one of the angles that you're supposed to find.
Right. So it's got 2 sides in the angle between, right? You see 2 sides in the
Yes.
angle between, cosine rule. If you see 3 sides, it's a cosine rule. If they hit you with anything else, it's a sine rule, right? So you kind of have to know which road to go, right? We've came to a branch. Do I go sine rule or do I go cosine rule? In this case, and we're going to go for the cosine rule. So this is going to be little c, this is going to be little b, and this is going to be little a. So I've identified that it's a cosine rule, and the question wants to find this distance. So I know it's a cosine rule that starts with the c squared, but I'm not going to ask Katie because she doesn't do it this way. But for the rest of us, what's the formula for c squared?
A squared plus B squared minus 2AB cosine C.
Are we good with that? Right, formula for c squared. Now in this case, the a is 2.42 and you square it. The b is 3.31 and you square it. And then it's 2 times that guy times that guy times the cosine of 40.3. And I'm just going to leave it at that. Would you agree it's pretty straightforward to finish? Right. Calculate the whole thing and then take the square root. You got a puzzled look, Matthew. What's not good?
Oh no, I get it.
You're thinking, okay. Thinking and puzzled look could look the same. Right, now, the next one, again, I'm only going to set these up. I'm not going to take them all the way to the end unless I think it's necessary. So a car is traveling along a straight road heading east for an hour. There is no picture to this one, so I'm drawing it as we go along. Then it travels for 30 minutes on another road that is northeast. So northeast is that one. The car is going 40 miles an hour. So that's 1 hour, 40 miles an hour. That's just them telling me that that distance is 40 miles. And then half an hour in this way, well, half an hour at 40 miles an hour makes this 20 miles. And we are being asked to find how far away from the starting position. Does that make sense, right? 1 hour at 40 miles an hour, half an hour at 40 miles an hour, and this guy. Now, it might look like we're missing stuff, and we are. I need to find, or we need to find, one more thing before we can solve this question. I'll call this little a, call this little c, call this little b. The thing that's missing is that angle. There's north, there's east, that's northeast. Okay, northeast. If I add a little imaginary dotted line, that might give you a clue how we're going to find B. What size is this angle from east to northeast?
45 degrees.
Right, would you agree that this little guy in here is 45 degrees, right? So how big is the green angle?
$135.
Do you see how you had to go hunting for the angle? It wasn't given to you, you had to figure it out. We now know everything that we need. Would you agree it's a cosine rule? Two sides and the angle in between. And in this case, we're looking for angle B, or sorry, side B. So it's going to be a squared plus c squared, take away 2ac cosine of b. And then when we put in the numbers, it's going to be 20 squared plus 40 squared, take away 2 lots of 20 times 40 with the cosine of 135 degrees. And that's where I'm finishing that question. Are we okay with that? The next one does give you a picture. It looks like the X and Y axis, but it's also representing compass points, north, south, east, and west. And we've got two boats. One boat is going in this direction, and this boat makes an angle, so it tells us this angle here is 50 degrees. Evidently, for those in the Navy, that is sometimes called north 50 degrees east. I guess if you're into sailing, somebody just nodded, so they do actually recognize that. And you got a second boat going down here, and this angle here is 70 degrees, and evidently, for those who want to know, that's called south 70 degrees east. So evidently, that's just a way of telling it. Now, what else do we know? The first one, that's this one here, is going at 20 miles an hour. And the second boat is traveling at 34 miles an hour, and only 1 hour goes by. And we are being asked to find their distance apart. So the only part that's missing is that this is 20, that this is 34, and that we're trying to find this guy. Now, to be able to use the formula, you've got to give the triangles A, B, and C, right? So everybody knows who it is. It doesn't really matter who you call A, B, and C, but you got to call them A, B, and C somewhere, right? I could have said A, B, C, and it would have worked. Now, for my naming, A is over here, little c is here, and little b is here. And since we're being asked to find the distance that these two boats are, this is going to be an a squared question. And so that's going to be b squared plus c squared, take away 2bc cosine of a. Are you comfortable about where this picture's information came from, and that that's the one that's going to tell me the distance from here to here? So you plug in your numbers and take the square root, and you're done. Any questions about that? Are you comfortable about what we've done? Oh, I just noticed something that was missing. I need to know angle A, don't I? I almost missed that. What size is angle A?
60 degrees.
Correct. Tell us why.
It'd be 40 from the top and 20 from the bottom.
Oh, that works. I was going to do 120 take away from 1A, but what you said is perfectly fine. That works. Right. And you need it because here has to be the cosine of 60 degrees, right? You needed that. Okay, last question, then we can look at identities for the time that we've got left. Question 20. Okay, this one has no picture. So a pilot flies in a straight path for a 1 hour, 30 minutes. So I'm just going to make the straight path up the way. And he travels at 550 miles an hour, and he traveled in that straight path for 1 hour 30. So I'm going to find out how many miles that is. Okay, so 825 miles that way. Okay. She then makes a course correction, heading 15 degrees to the right of her original course. I wish I hadn't made this picture so big, but never mind. That's the original course, but she went this way and she went 15 degrees to the right. Does that make sense? She went 15 degrees to the right. And she did it for 2 hours. I know it's not to scale, but 2 hours at 550 miles an hour is that guy. And we are being asked yet again, how far from the starting point is she? So you went that way for 820, changed course and went that way for 1100, and now you're from here to here. Although this is an aircraft, don't you do very similar things when you're on the boat, right? You travel, you change course, you travel. The number's much smaller. Now I'm going to call my triangle because I want to A, B, and C. I know little A is 1100. I know little C is that guy. If I can find out this angle, then I will have 2 sides in the angle in between, which means I can find what we're being asked, the third missing side. Okay, how big is the missing angle? That angle in there. What size is it? You know this guy. How big's him?
167.
160. Well, that might look like a 3 because my writing's
Oh,
very-
sorry. I have mine open at the same time, so I can make sure I'm on the same
Right,
page.
so it's 165, right? In this case. So you have everything that you need. In this case, you're going to be looking for a little b. So it's going to be b squared equals a squared plus c squared. Take away 2ac cosine of b. And it's going to be 1100 squared, 825 squared. Take away all that other stuff, and you are finished. I don't think the applications were too bad. Some of the ones that were written, as you read it, build the picture, and when you're finished, there'll be a triangle. And the most likely question was going to be find a missing distance, right? Find a missing side of the triangle. I wish they'd put in, find a missing angle, but they didn't. Are we good? Any questions before we close the door on this and move on? Okay, that's you done everything you need for the homework and for your online test. The next one is a kind of introduction to our new chapter. So we're starting chapter 8. Chapter 8. That's me definitely thinking chapter 7. In particular, we're going to do 7.1, and these are trig identities. A lot of people find trig identities confusing or difficult, and I can understand why. But the more practice you get at them, the better you will become. Essentially, there are 2 kinds of trig identities. The first kind you could put into the line of simplify a trig expression. So what that looks like is you're going to get an expression with sines, cosines, secants, all that good stuff, right? And your job is to make it look nicer, right? What we would call style points. So you'll get a question that will just say, simplify the following. And we're going to use this process, trig identities, to do it. And the second type is they give you the simplified version, and it's your job to prove it. In a lot of ways, this is much easier, because what they do is they say, this ugly guy is equal to this thing. So it's a bit like they told you the answer, which is kind of helpful, because then you know when you get there to stop. It's a little bit harder to know that you've simplified something as much as possible, right? Because there might be something else that you might be able to do that you didn't notice. But when you get an identity, And that's what these are very often called trig identities as well. They tell you what the answer is, and it's your job to prove it. So you need some building blocks. And what I mean by that is there are certain trig expressions, trig identities, that we should memorize or at least know so that we can use them to do these jobs. So here are some, most of them, I hope you've met before. I'm trying to think, I'm going to use Thea, right? Do you all remember that guy? That a sine is 1 over a cosecant and a cosecant is a 1 over a sine. Haven't we already used that, right? That's an example of it. Can anybody tell me an equivalent version for a cosine?
1 over secant.
Okay. And if you kind of, husband and wife deal, if you switch them round, right, that's also true. So what does that mean? It means that if I see a 1 over cosecant, can't I write it as a sine? And if I see a 1 over cosine, can't I write it as a secant, right? It gives me, this is the same as that, right? They are identical, right? Identities, right? They are the same. The third one is that a tangent is 1 over the cotangent, and that a cotangent of an angle is 1 over the tangent. They even have a name for those if you want to know them. They're called the reciprocal identities. Don't need to know the name, but that's what they're called. Here's one that everybody knows. What is sine squared plus cos squared equal to? That's right, it's equal to 1. The tan of theta can be written as sine theta over cosine theta. Do you remember that one? Sine theta over cosine theta. Can anybody remember the least common version of that? What is a cotangent of theta if you write it in terms of sines and cosines? That's what a tangent is equal to. But what's a cotangent equal to?
Cosine over sine.
Cosine over sine.
Yeah, cosine over sine. Now, we will be adding to this list as and when necessary, right? But that's a good bunch of guys to start the ball rolling. So the kind of questions we're going to get, let's load them up, could be something like question 1. Simplify 4 cosine t times tan t. One of the strategies you can use is to turn everything into sines and cosines. So I have 4 cosine t, and I'm going to replace tan with a sine over cosine. So far, so good. Now, can you see anything that might cancel and simplify down? Something on the top is allowed to cancel the same thing on the bottom.
The cosine t.
And what we're now left with is 4 sine t. So would you agree that that is simpler? And I can't think of anything else, so I know I'm pretty much finished. How about this one? Oh, they're using x, okay. Tan squared x, take away secant squared x. Ooh, Okay. Well, tangent is a sine over a cosine. So this becomes sine squared x over cos squared x. And a secant is 1 over a cosine. So this becomes 1 squared over cosine squared. So far, so good? Okay. Now, since they share the same common denominator, I can now write it like this. And we hit a kind of roadblock, because you'll look at that and you'll probably quite reasonably think, that's the end of the road. I can't do any more. But that's actually not the case. Do you remember this guy here, sine squared plus cos squared equals 1? Remember this guy? There are lots of different ways of writing that same piece of information. For instance, isn't sine squared theta 1 take away cos squared theta? Well, if you take cos squared away from both sides, don't you get this guy? Another version, I'm saying, that's meant to say sine, I apologize. Isn't cos squared theta then 1 take away sine squared theta? Great. Now, that guy there looks very like this guy here. Not quite, but it looks very like it. So I'll put it in a little bubble over here. Cos squared, I'll call it x, is equal to 1 take away sine squared x. Right? And sine squared x is 1 take away cos squared x. Right? Then one way of doing it is, couldn't I use that for sine squared? So let's see what we get. Sine squared x can be called 1 take away cos squared x, take away 1. So I'm replacing sine squared x with 1 take away cos squared x, and then I'm subtracting 1. Can you see anything nice happening here? What can the top become?
Negative cosine squared x.
Yeah, don't the ones cancel each other out? Wait a minute. Negative cos squared over a cos squared. Shouldn't they cancel? And the answer? -1. So that expression, turning everybody into sines and cosines, collecting them together, and then realizing that sine squared could be written in this format, and then you get to here, and then you get a nice cancel. One of the problems with, simplify the expression is, couldn't you quite reasonably think that you'd finished when you got to there? Yeah, that looks nice. What you might not notice is it could go further. And so sometimes that is the answer, right? Sometimes that's as good as the answer should get. But it's always worth trying out some other things. And then if you try out something and it ends up looking even worse, then you know, well, that wasn't worth doing. But you can't be sure it's not worth doing unless you do it to see what you get, right? So if you see a sine squared, think of it as being 1 minus cos squared. If you see a cos squared, think of about maybe making a 1 minus sine squared. And
So-
off you go. Mm-hmm.
So couldn't you, when at that step that you said that we might think that it was that one? Yeah, okay.
Mhm.
Couldn't you multiply the top and bottom by -1?
Oh, that's an interesting thought. Let's see what that would look like. So it would look like minus sine squared x plus 1 over negative cos squared x. Okay.
And so overall,
Uh-huh.
that would be 1 minus sine squared.
Uh-huh.
Yeah.
Okay, keep going.
And then that equals cosine squared.
Yeah. And you get -1 again.
Okay. Sounds good.
So what's that phrase? There's more than one way to skin a cat, right? Trig identities. I mean, you get the right answer. So whatever makes more sense to your brain is fine. Okay, perfect timing. You want to put your last name down?